In this video, we will use the transmission system example to look at the quasi-dynamic simulation function. The project should have study case 06 quasi-dynamic simulation active together with the base scenario. Note also that there's a network variation called HVDC link. To start with, this variation is not activated. The purpose of quasi-dynamic simulation is to allow load flow analysis of a network over a period of time, for example, in order to study the network under different demand conditions. In this particular model, the loads and generators have been associated with characteristics to reflect the seasonal and daily demand variation and the variability of wind and solar generation. Here, for example, is the profile applied to loads to reflect typical winter weekday demand. The quasi-dynamic simulation toolbox should be selected. Before setting up the simulation, we can use this icon to define which variables we want to record. Certain variables are recorded by default, for example, voltages at terminals. For this exercise, we will just use these defaults. The quasi-dynamic simulation command dialog is opened using this icon. The time period can be set to a standard length or a customized range. We'll look at just 1 day. And for the step size, we'll use hours. The simulation is executed. Reports can be generated using this icon. For example, a report on voltages. It's possible to see whether low and high voltages occur and at what point in the day. We can see that the lowest voltages on the transmission network are in the NW03 substation. Let's copy this element so that we can create a plot of voltage over the day. This icon is used to create plots with a default range of plot types offered. We'll create a simple curve plot. We paste in the element reference and select the variable to be plotted. Then the plot is generated. It can be seen how the voltage varies, being lowest when the system demand is high. Let's now run a report to show the loadings on the network elements. We can see that none of the elements exceeds its rating during the course of the day. However, in reality, a network is likely to be affected by planned outages. Returning to the simulation options, we see that there's a page called Maintenance and Events, where an option can be selected to consider planned outages when running the simulation. In this example, just one outage is relevant for the time period. It's an outage of one of the Western interconnector circuits. Let's mark this in graphic. We can see that this outage may result in overloading on the adjacent circuit. The quasi-dynamic simulation and loading report are now rerun. The adjacent circuit is now heavily overloaded at the time of peak demand. To manage this loading, it would be better if more power would flow through the northeast-southwest interconnector. So we will now consider a situation where this line has been replaced by an HVDC link which can be controlled to manage the power flows. This is modeled using a network variation which can be activated. If we right-click on the HVDC link, we can look at the model in some detail. The settings on this converter are used to control the power flow. On the load flow page, we can define the load sharing using active power participation. A boundary between the northwest and southwest has already been selected. A participation factor of 1 is set, which means that the HVDC link will carry the same active power as is transferred across this boundary. We can see this if a load flow is run. Now, rerunning the simulation, it's seen that the worst loading is reduced. Further adjustments can be made. The sharing factor can be increased so that no circuits are overloaded at any point in the day.